So luckily, Marco gave us a great segue into what we're going to talk about today. So he talked a little about real time and how it's a bit tricky. So what we're going to do is share our experience at Trainline about enabling data science to deliver data products to our customers. We're going to go back to the dark ages and talk a little bit about batch and what problems we solve there. But then hopefully we'll kind of share with you some of our experiences in the real-time world. So if you don't know already, you're in the Trainline office. So who are Trainline? We're Europe's leading training coach app. So we have integrations with 220 inventories across Europe. So I think there's 25 in the UK. We're a pretty big e-commerce platform. We have 80 million monthly active users. And I think, what does it say here? 204 tickets every minute. So yeah, that's Trainline. So who are we? So I'm Sam. Unfortunately, my name's Sam Taylor. I would like to have changed it, so the guys at Day Idols couldn't take the mick out of us. But so yeah, I lead up the machine learning efforts at Trainline. A bit about me, what am I passionate about? So I like to restore any VW, historic one, obviously. And then in my spare time, I like building data products that give our customers great experiences.
Yeah, go on. I was going to change my surname before the talk, but hyphenating it to Taylor would have been reasonably redundant. So I'm Dan. I run the data engineering team here at Trainline. Hi over there to the people from the data engineering team. I'm passionate about restoring any classic Land Rover available because I'm at heart a patriot. You only need...
There's going to be anything like this in here.
I know, it's good, yeah. I told you not to bother writing a script. So, in my professional life, I'm very passionate about applying data or applying engineering principles within data. I think that's something that hasn't been done enough. And I think that's something we all pay the price for every day. So, yeah, that's my thing. Shall I carry on? Right, so as Sam just said, Trainline, if you ignore the train part of what we do and the coach part of what we do, is a traditional e-commerce platform. Under the hood, there's some clever stuff that we do about finding people decent prices on train tickets, but generally what we do is sell stuff online. And in a lot of respects, we're a very typical e-commerce site. And I think on the front end, which is maybe somewhere we don't think about enough as data people, the world's been changing a lot over the last, 5 years if you go to conferences, 2 years if you've actually been working at a company doing the changes. We've been changing more towards a kind of microservices architecture. And lots of companies are moving away from the world where it was one monolithic database, one monolithic background, application, and generally one channel that you'd be delivering across, which would be over the web. So now I think we've got something like 4 different channels over 2 different kinds of app and 2 different kinds of web, and an absolute ton of back-end services. So I've done like a simplified example there on the screen where we have different services now to do the search, we have services to manage the inventory, to do the payments, bookings, fulfillment of bookings and all that stuff. Never mind all the stuff on the front end, we've then split into kind of microservices on the back end too. So customer feedback comes in via one sort of direction. We're using things like Google Analytics to do our sort of tagging and tracking on the website. We're having feeds of stuff coming in from the industry in the background. And then like a lot of companies, we've also got these legacy data warehouses and data lakes that maybe we don't like to talk about, but still have to admit that they're there. Now, microservices is a wonderful thing because it allows companies to grow. And as a result, really, we should kind of respect it and kind of learn to live with it. One of the side effects or one of the big strengths of it, and one of the side effects, is that you end up with multiple teams involved in delivering any given feature. So you've got a desktop web team and a mobile web team. You've got an apps team. There's actually 2 apps teams. You've got a team who do search and a team who do inventory. You've got a team who do payments, a team who do bookings, another team who do fulfillment. You've got a team who are responsible for maintaining the feeds from the industry, and a team that do customer feedback, a team that do analytics. Don't like those guys. Only kidding. They're great. And a team who maintain your legacy warehouse. So that's 12 sets of people. So now if you want to understand anything that's happening, anything that your customer's doing, you can't just go to a big dirty old Oracle database and ask. And that's a massive problem for people working in data. Hands up if you've never experienced that problem. There you go, QED. So it makes it very hard for data scientists. There is a data scientist. In order to access any of the data that you need to really understand a customer's journey through the estate, you have to go to all of these places, and that is a very sad experience. Can I do that animation again? I really enjoyed that. And there's nothing new here, right? This is a common problem, and it's common, I think, to all e-commerce systems. I think what I've not put in the slides is that often data is seen as a second-class citizen in this. A lot of the front-end teams are being driven to deliver user-facing features, and often they forget to maybe store some of the data about those user-facing features in order to get there. Obviously, that never happens at Trainline, but at previous employers, we experienced that a lot. And this is the solution that we've come up with here. So this was a big thing, and I'm lucky enough to have only been at the company for 4 months, so I missed the rollout of this change. But it was a huge change, both in terms of the technology and in terms of the kind of interpersonal elements of managing through a big change. So what we put in place was something called Vortex, which is a kind of a data gateway. It's a single REST endpoint to which all the front-end teams, all the people across the whole business, send data as it happens. So that doesn't sound that impressive, really. It's only a REST endpoint, but it's something like 250 different event types and something like 2 to 3 billion rows of data that we process through that per day. It's not really rows either, because each of those data items is a bloody enormous JSON document. So there's a huge amount of data that flows through that. And you can imagine the friction we had organizationally with the teams to put that in place, where each of those teams now has been forced to send a load of data that they'd really rather not be sending. They'd rather be changing the color of a widget from blue to green or whatever. But anyway, that happened, and that's great. And I made a point of joining the company shortly afterwards. So what we then do once we have that data inside the data engineering estate is a pretty simple process, but we do it at a reasonably large scale. So we take those JSON documents, and first of all, we validate them against a schema. So we make sure that the front-end teams are sticking to the kind of rules and the agreement that we have with them. So we use JSON schema for that. It's pretty standard, pretty simple. We just validate that, fields contain values when they should, that the document has the right structure, and that it's properly formatted. We then run it through a kind of a cleaning process where we filter out stuff we don't need and we tweak stuff into the right data types, and then we flatten it out. And that can be quite a huge explosion in terms of the volume of data, because many of those are quite deeply nested JSON documents. And finally, we do something that I've always called modeling, but for the sake of this talk, I'm going to call feature extraction, because I'm trying to connect to you people. Which is basically we start to convert that event-driven data into something that actually represents entities within the world. So things like customers, or a train, or a service, or a ticket, or a payment, or whatever it might be. And then finally, we chuck it all in a big bucket. And I'm almost ready to hand back to my husband, but before I do, I'm going to talk about kind of one of the obvious problems organizationally about this as well, which is that you might have noticed that we've made ourselves a pinch point between absolutely everyone and literally everyone. So all the front-end teams now have to come through data engineering if they want to send any data anywhere or do anything. And all the back-end teams, if they want any of that data, they have to come to data engineering in order to get that data. And you can obviously see that I think there's about 7 or 8 of us in the data engineering team at the moment. That's obviously a bit of a problem with a company with a staff of 250 developers. So we're very scared, they're very angry too. The solution to this is, well, to not do it. And this comes from a paper called Optimize for Autonomy, which you should all go and read. It's quite old now, but I think everybody should just go and read it. The key thing is to empower other teams to use data. And everybody says that all the time. And what that actually looks like is allowing them both self-service access to the data once it's at rest. So you've given them a carrot. You know, this is why you're sending us the data, so you can go back and query it with Athena later on and check that you had the right number of orders. But also to allow them to inner source the data as they put it in, so that they can put it in at their own pace. They don't have to wait. They're not blocked by your backlog. And across all of that, of course, you need a very stringent data security policy to make sure that nobody's, you know, leaking sensitive information or treating data in a kind of disrespectful manner. So, I'm delighted to say that we nailed it. And we are genuinely now at a point where we do have 2 or 3 billion new rows on 250 plus schemas arriving into a big data lake every day, which hopefully makes people like Sam happy, because it gives them something that they can actually use, both for experimentation, for model training, and for cool data science stuff, which I'll now allow Sam to talk about.
Thank you. Yeah, cheers. Okay, yeah, so as Dan has said, he has now provided us all the tools necessary and all the data necessary in this nice formatted way. It's beautifully modeled, or features have been created. I argue we did that, but all right. So we needed to figure out what we're going to use this data for. So we're collecting all this data from our customers. What can we give back? So that's at Trainline what data science is all about. It's about delivering data products that really help the experience of our customers. So we had to figure out what to solve first. So luckily, we have a great customer research team that went out to the market and asked our customers, what's really important to you? What do you need in our product? And they came back with a ranked list. And quite obviously, at the top of that list, it was all about price. So price around understanding. So in the UK, there's huge complexity in train prices. You obviously have advanced tickets, off-peak, super off-peak, anytime. What does that mean? I don't know. They want to be able to find the best price, and they also want to be able to plan around pricing. So that's where we came in. So we decided to build a tool called price prediction. So this tries to answer the question, how long do I have until this current price band is going to sell out, and therefore the price is going to rise? So in the UK, advanced tickets start to be sold about 3 months ahead. So you might come to Trainline 3 months ahead and you might see the cheapest price. Okay, that's great, but perhaps you've not solidified your plans at that point. So what you really want to know is, okay, I know I want to kind of pay this price. How do I plan? Or how do I figure out when I need to solidify my plans to get it? So we built a couple of MVPs and got that out to the customer to understand if it was useful. And now we're on our third version of this. So in the app today, this is currently what price prediction looks like. So you do a search from A to B. You then get your search results, and you're able to view this is called Price Tracker, and you're able to see the progression of prices for this ticket, for this journey that you're going to take. So currently it's £32, and this is price prediction. So you have 3 days to buy this price before it goes to 37. Or you can wait till on the day and you have to pay £96.20, which is obviously a lot of money. Well, it's 3 times what you could pay today. So we've had some great feedback from our customers. So we've done some analysis and we figured out that since we released this our customers to say £10 million, which is obviously great for our customers. But we've also had, perhaps not great for Trainline. It's all about the customers, right? We've also had some great feedback from the industry. So last year we won the UX UK Awards for Best Information Experience. So that's obviously something myself and the data science team, obviously the data engineers, holding us up, propping us up.
I wasn't here.
Okay, the royal we of data engineers that you weren't part of, but you could have taken credit for that then. So yeah, we're really proud of it. So let's go into what price prediction is and what it has to do. So obviously there's a huge amount of variation in the train ticketing in UK. Let's just talk about UK. We've not got to Europe yet for price prediction. There's a lot of data and there's a lot of variation in that data. So you have to build some pretty scalable machine learning to be able to solve this prediction task of predicting when this price is going to sell out. But essentially the problem that you're trying to solve is how does supply and demand affect when a price will change. So you can imagine that train operators will change how many tickets you can buy at a particular price band, which means that might sell out quicker if they have a lower amount of them. Or demand from our customers can severely affect how quickly the tickets rise, because of perhaps seasonal trends or commuters buying a lot of tickets over the week, or in fact big events such as Glastonbury. So to be able to solve this problem, we needed to figure out what kind of model we needed to use. So we went through a couple of iterations. Eventually we settled on a fully connected neural network, specifically with embedding layers. Now the reason I highlight that is because that was the kind of selling point. So we have lots of very high cardinality features. So you can imagine that, like the previous slide said, there's 24,000 unique journeys. That's high cardinality. When you start crossing that with the ticket types, you get to hundreds of thousands. So we found that this is the best way to exploit that and exploit the variations in supply and demand. And actually handle the data that we had to throw at it. So not only was this model accurate, the embeddings that we got out of it actually gave us some really interesting insights. So for example, we found that in this embedding space, sorry, I did point to my screen then when you took the mick out of me earlier about doing that. In this embedding space, we're able to visualize this, and we found that the inverse of a route, so let's say you took Paddington to Bristol, was very close together with Bristol to Paddington. Now what that means is those routes are selling out at similar rates, which is kind of obvious, right? People have to go to a place and they have to come back, so there's similar demand. But we found other things in there that I won't go into, but it's really helped us. It's a secret sauce. It's really helped us build some of our future features, because data science is often a lot about domain expertise, and these embedding layers really helped us kind of develop that domain expertise. Okay, so now back to a bit more of the kind of how we got this out. So that's how we trained it. That's how the model was built. So how do we actually scale this up and run it in production? So we found a couple of things were very, very important. So we wanted to train kind of once a month, and we wanted to infer daily because we're currently still in batch mode and not got to real time yet. We found that it was critical to have your, see this is Dan's nice data lake, right? He's modeled that for us, it's brilliant. It's not blow too much smoke up his ass, but what's really useful is so this is our model training world. We want the same code to run in our offline training and evaluation stage as what we do in inference. Now the reason we need that is because if we see that tomorrow our accuracy is just plummeted, then we know that it's not, and we've not changed this code, we know that it's not the training or inference, it's not the difference between that code, it must be the data. So we've removed one of the combinations to debug what's happening in production. So then we do our inference every day. We predict this when a price will rise, and we actually have to get that to our Trainline customers. And we have to do this at scale. So we have about 6 million journey searches every day. I think at peak it's about 1,000 a minute. So Trainline customers are trying to get hold of these predictions really quick. We also needed to be able to roll back these predictions instantaneously if something went wrong. So to do that, in conjunction with the data engineers, I look at Dan, but he wasn't here, we built a technology called Optimus. And luckily for you, this is also open sourced. So what this does is it puts a layer on top of, in this case, DynamoDB in AWS, and allows us to have transactional ability on whole prediction sets. So let's say you have your predictions in production yesterday that you did your daily inference on, and today you want to reload, you want to load new ones. Now what would happen if you just use a normal database is that partway through the load you'd be using today's predictions and yesterday's. You might say, what's wrong with that? Turns out it's quite annoying when you have to debug what someone saw and trying to kind of link back what experience someone got. So what Optimus gives us the ability to do is load a data set one day with our predictions, the next day load it up, and then once it's all loaded, we'll do a switch, which means if we have something wrong, we can switch back instantaneously. So that works really well for us. And plug for it's on GitHub. Go and take a look. Okay, so we've built all this nice stuff in batch. Our customers really loved it. You obviously have to do something else. And that's where, actually we did say this to you, Dan, you were here at this point. We said, we have another problem. It's very similar to price prediction. It uses many of the same features, but this time we want it in real time. And I know your pipelines run in batch, and I know the data lakes populate in batch, but unfortunately, we want to do it in real time. So we had a little think, okay, what can we do to start with? So perhaps, let's build our model in the offline world in batch. That's fine. Take that model and do real-time inference off of Vortex. So that's the hub that Dan showed at the beginning. Then we had a little bit more of a think about that, and we thought, oh, okay, we've unpicked all of the data engineers' nice stuff that they've given us. So we've got to use the messy data that we didn't want to use. It's not flattened, it's all in JSON. And we thought, okay, how do we process in real time? What technology do we use? How do we test this? This code is now different. So one of the things we learned in batch mode was we want the code to be the same. And that doesn't allow this in this case. We've got to do our feature extraction in 2 different modes. And in fact, probably over multiple messages. So as Dan said, he would have provided one nice table. So that obviously doesn't work very well. And there's actually a really good paper from Google called the Hidden Technical Debt in Machine Learning Systems. It's a great paper that they've obviously got a lot of experience at Google about doing the wrong way, because it's a very insightful paper. But what they argue is there's a couple of prominent lessons from getting machine learning into production, and a couple of pitfalls that you can hit. So they talked a lot about unstable data dependencies. So we've just introduced that, right? So we're now using the JSONs. They can change from the teams because they might want to change what they send into Vortex. So we've introduced one of the cardinal sins that this paper suggests. What they also suggest is that the actual machine learning code, so the model, is actually the smallest part of the system. And that's kind of right. It's the actual code to train your model is not really that complex, right? Unless you're building kind of something from scratch. What's complex is all the piping around it. And what we're doing now is, in how we initially thought about doing real time, is exploding this section. So our feature extraction is now grossly outweighed in comparison to everything else because we've got to use these two different data sources. And the inaccuracies that come into that, they just make your model useless. So what I'm hoping is Dan's going to come in and save the day.
Yeah, totes.
Maybe with a cape or something.
Yeah,
or another beer.
I've never told you this, Sam, and I don't think this is really the right time in our relationship, but you're not the first person to ask me for this. So, we should have chosen a different running joke for this presentation. Anyway, it turns out the rest of the site, the ones who aren't making neural networks, are also reasonably interested in doing stuff in real time, because it turns out customers exist in a real time space as well. There's no point telling somebody about a disruption 24 hours after they traveled on a train, for example. So there's a huge business pressure, not least from Sam, to build a real-time capability with data, which is great. The problem is we've just built a batch capability with data. So this is all about kind of moving from one to the other. There aren't many slides, but it's very important, so please pay attention. So this is what a lot of companies end up doing. And this is basically the mistake, I think, that maybe Sam was describing. So at the bottom there, we've got the batch pipeline that we talked about earlier. So you've got validation and flattening and feature extraction / modeling. And it all goes into a data. Modeling. And you do your training of your machine learning models in that space, but you're also running all your business reporting and your BI and all that other kind of stuff in there as well. All the kind of boring stuff that pays the bills. So that's there, and it's real and it exists. But then you want streaming, so you go off and you go, oh, all right, Kafka's brilliant, we'll go and implement Kafka. Now Kafka is brilliant. It's without question the finest product I've ever used in the data space in the last 20 years or whatever. But the key thing is that you can't implement it in isolation, and a lot of companies do that. And I think the key message for me here is that the jump from batch to streaming to real time is just as big as the jump from all those disparate data sources to having one common place where you could find all of the data. And the reason is because if you're streaming data that's different to what's in batch, if it's different to the reports that are going on the execs' desks every day, if it's different to what's training the models, then the results you get in real time will be different to the results that the rest of the business is seeing. And that's why we're very keen on this, which is this kind of single source of truth philosophy, and why Olivier, my esteemed colleague and friend, who's probably now left the room, there he is, hi, is working on a new thing called Whirlwind to make this whole thing true. It's very important to, when you move over to streaming, to pull that modeling logic up from the batch world and promote it right the way up to streaming. Because what that means is then that you've made all those models available to people like Sam in real time. So here we've got exactly the same process based on Kafka, where we're receiving the raw JSON events from the business, just like we always did. We're pushing them into Kafka. We then run a clean process and pop them back into Kafka on a different topic. So they're now available for people to use downstream. We then take them out and flatten them and push them back onto multiple different topics per event back into Kafka. And then we take them back out again and we do our modeling / feature extraction or whatever, and pushing it. I've totally mislabeled that diagram, I just noticed. Don't take a photo of that one. you then push that back and you get those features. The brilliant thing is, and one of the wonderful features about Kafka and Kafka streams and all those sorts of things that I don't necessarily have time to talk about, is that they'll do a lot of that real-time to modeled transformation for you. So it's actually not that difficult a process to do. And then on the very end of that pipeline, you just drop it back down into the batch world. So at the end of as it streams all the way through, you pull it out the topic. You can just pull it out once a day. You dump it down into your data lake. And it's available there just like it always was for people to use. So all your BI reporting remains the same, and all your business knowledge remains the same, and your model training remains the same. But it's also perfectly in sync with all the stuff that you're doing in real time. And I think if you don't do that, then you're basically just making life harder for yourself. You're going back to that world where there were multiple sources of the truth. So here's a more in-depth, you can take a picture of this one if you like. Here's a more in-depth diagram. I'll give you some time to do it. More in-depth diagram of our architecture. It's not 100% true, so don't go and build exactly this. It is more complicated. Just because this one's in draw.io doesn't necessarily mean it's real. But you can see through there the flow of data through that Kafka system, and then it drops down into storage at the various points through that pipeline where that's relevant. So the first time it drops down into storage is into what we call the acquired bucket. The acquired bucket is like our ultimate backup mechanism. So we don't run a backup in our Oracle database every week. Well, we probably do, but we don't really care. We drop those events back down raw as we receive them. So if the whole world explodes, we can just play them back through. There are about 3 people in the business who have access to that bucket. It's very tightly secured. We then drop the data down into those buckets at various stages along the way, and then in the end we'll do some stuff in batch on the bottom there in order to generate reports and things like that. But it also gives us up at the top there the ability to build these cool real-time components. So, I think you were going to do this last slide. So that's what we built for you, Sam.
It's a good picture.
You happy with that? Shall I do that?
Yeah, you do.
All right, then I'll do that.
Take it.
I love you. So, they went too far.
It's gone too far.
So, yeah, maybe the possibilities are endless. So I'm very excited to say that the first Kafka-driven product that we built at Trainline went live today at around 3 o'clock. So if you're an iPhone user who's booked a ticket for a train that has a disruption, you might get a notification telling you that your train's been delayed, which might be quite useful. And you'll know that somewhere in its distant past, that message has its origins in a Kafka system that 2 drunken men talk to you about at a meetup. But there are so many more possibilities. I'll let you talk about those because you wrote the list.
Yeah, I wrote the list.
Yeah, go on. I just did SpongeBob.
No, the list was off the top of my head. So yeah, obviously, we could have real-time feedback loops. So price prediction would be really nice to understand how accurate it is in real time. Personalization. So this gets into a bit about what Marco was talking about. So the online learning type stuff, personalization in real time, exposing better and more up-to-date data to our customers is a massive thing. That I think would be very useful. So yeah, I think the possibilities are endless.
I think you're probably right.
I think I am.